Good morning, DevOps Days Amsterdam. Woo! Yeah. I'm thrilled this morning to be here and to share some of the lessons learned in utilizing systems design in the air traffic control domain. But let's start with a game. So we're going to have an objective. We'll need to complete a set of tasks. We'll also have a constraint because we're only going to have 10 seconds to do it. So are you ready? Come on. Yeah. All right. At 8, clap your hands once. At 5, give yourself or someone a high five. At 3, clap your hands twice. Don't perform the steps above. Just say DevOps Days. Wow. That was awesome. What a way to start a presentation with applause. So let's unpack what happened there from these 10 seconds of chaos. So we tend to start doing things before we've read the requirements. Not only that, requirements tend to change. What seemed important early on may be irrelevant later. Now you might think, hey, Gabriel, you did all of the steps with us, and that was a bit misleading. True. But your team lead or speaker doesn't always have the complete picture up front. So let's say you followed only the last instruction. Then you were technically correct. But if you followed everything, you had more fun and a bit of confusion. The point is, humans are complex. And even simple coordination is hard at scale. And getting a room full of DevOps pros to clap at the same time, that is not easy. So today I'm going to take you on a mission. I want you to really think about a project you're working on, or maybe have worked on in the past, where you maybe had to develop something or just complete a set of tasks. And this might be a project where maybe the requirements were unclear. Maybe you haven't done it before. It could also be, and I'm pretty sure we've all had this, that you had to do with cross-team collaboration complexity. That means some of the communication lines between product teams just didn't go that well. And maybe, just like I did, you had to do it in a high-stakes environment. So think of that and take that project with you in the mission today and follow me through my journey into systems design. So my name is Gabriel Pretorius. I'm a lifelong learner. I love learning new things at home and at work. At home, I love spending time with my wife and my daughter, with friends and with family. But I'm also quite at home at 2 a.m. in a data center or outside wearing a hard hat, designing, maintaining, and supporting hardware, software, and network infrastructure as a systems engineer. For the past 5.5 years, I've been able to do that at Air Traffic Control, the Netherlands. And especially in this tower. So I've worked in their tower operations team, where the tower air traffic controllers make use of air traffic management systems to ensure there are safe flights in and out of the Schiphol control zone. These air traffic management systems operate 24 hours a day, 7 days a week, and 365 days a year to ensure we can all go on vacation or visit friends and family abroad, do business, all in a safe manner. Wow, these air traffic controllers really have a great office view, don't they? And I don't know about you, but their monitor setup definitely beats mine. So to create some situational context for this talk today, I'm going to need to define 3 of the topics in this talk. We'll start with air traffic control applications, which is a subset of air traffic management systems. We'll define complex problems and also look at systems design. But I've got a challenge for you, and we'll make it an incentivized challenge. So I want you to try and identify some of the similarities between them, and you might just get some elements richer. So really try to think with these M&Ms in mind. So we'll start with air traffic management systems. These are systems and services which are integrated, and they enable the safe and orderly movement of aircraft through controlled airspace. They use real-time data, surveillance, and communication technologies. Complex problems, these are issues with interconnected parts, unpredictable outcomes, and doesn't have one single correct solution. They often involve human behavior, changing conditions, and require collaboration, continuous learning, adaptation to manage effectively. And finally, systems design. This is the process of defining the architecture, components, interfaces, and data flow of a system to meet specific business or organizational needs. It involves engineering a coherent, efficient, and scalable system that fulfills defined requirements. So I would love to hear if you were able to identify some of the similarities between these. And I would love to hear from someone in the audience. Who'd like to go at it?
It's early morning, you know.
It's early morning. So now I'm going to need to point out and ask Tim, you've had your coffee. If you'd like to share something that you saw as a similarity between systems design, air traffic management systems, or complex problems.
This should be easy for me because I have an aerospace engineering degree, but I did it ages ago. So, and I'm supposedly an engineer. Well, coherent designs obviously are a similarity between system design and air traffic management.
Exactly. Tim, give a round of applause for Tim. Thank you for being a real player there. And you guys play the clapping game again, which is quite nice. But you notice, and Tim really touched on that, that already also in air traffic management systems and complex problems, they all involve people, humans. They need collaboration, and there needs to be some coherence between them. And systems design is a process which you can use to reach this outcome. And right there in the middle, there's an opportunity for some lessons learned. So let's take a look at it. Today we're going to talk about the structured approach of systems design. This really is a tool in a systems engineer's toolbox which they can use to break open complex problems and just manage how all of these different systems, maybe in your project, but also in my work as air traffic management systems, really work together. And then I'm also going to share some of the lessons learned. So we'll start with Russell Ackoff. He was a pioneer in systems thinking, and he said that a system is not the sum of its parts, it's the product of their interactions. This means that a system with multiple interfaces are inherently more complex, and making a change to such a system might be daunting. But that doesn't have to be if you've got something like a systems design, structured approach that can help you through this. It's like a magnifying glass that can help you uncover some of the things from the underlying components. And the systems design can come in many different forms, but we'll break the structured approach of the systems design into 4 different clusters. Each structured approach needs to start with a real understanding of the system and to define some of the requirements you need to reach your outcome. You then move over and design, do some functional design, go into some technicalities before you can move towards a prototype and plan integration of all of these different components. And finally, we get to the fun part, and we're going to deploy into production, and we're going to ensure it's supported sufficiently. But I want you to really see that there are also a lot of feedback loops. The structured approach is not meant to be traversed only like a one-way street. You're supposed to move between steps back and forth based on subsequent learning. And I've applied the structured approach and refined it during multiple projects at Air Traffic Control the Netherlands. But today I'm going to share with you based on these 3 projects. And that was the design of a 360-degree tower simulator, integration of electronic flight strips into existing tower simulator environments, and finally replacing an entire automatic terminal information service at multiple locations. And if I mention ATIS, that's just because it's baked into my brain. If I say ATIS, think of the last project. But let's just take a quick look at these 3 projects and what it is. So firstly, we'll start with an air traffic control tower simulator. These simulator or educational environments are meant to provide a submersive experience for a tower air traffic controller, where they can make use of the same tools that they use in production and where they can really exercise real-world scenarios. I love this photo because this photo, as you'll notice, a lot of the screens are still black. This was the moment we finally got the visuals to work, the 360-degree view of Schiphol Airport as a tower controller would see in real life. Then we'll move on to getting electronic flight strips into the existing tower simulators. So, whoa, hold on. What is flight strips? So air traffic controllers, you really have different roles. And each controller is responsible for just one part of a flight's departure. You'll have ground controllers which focus on getting a plane from the gate to the runway, throughout the taxiway. You'll have runway controllers, and each of these controllers needs some sort of way to say that, hey, I'm the owner of this flight. And they make use of paper flight strips in a lot of airports in the world, or electronic flight strips, which give them a digital strip on a big tablet or touchscreen, which they can use. So we had the objective of integrating an electronic flight strip system into some of the simulator environments, which still made use of paper strips. And finally, we had to replace an entire operational automatic terminal information service at multiple airport locations. This meant that we had hardware on-premise in a hardware data center. We had to do with a lot of network infrastructure. I even had to drive all over the Netherlands to go and visit all of these broadcasting sites, because the ATIS system, the Automatic Terminal Information Service, is a service an air traffic control environment has that provides pilots with automated information that they broadcast. And that could be weather information, runway conditions. And this is a service that a pilot can listen to. Or if you would like, if you buy a VHF radio and go and stand next to Schiphol, you can listen to it because it's broadcasted at these locations. So let's just jump into it. So when I started with systems design, and this might sound very familiar to you, my product owner walked into the room and said, "Hey, Jan Gabriel, so we need a new tower training simulator. And the training organization needed it yesterday. Will you design it for us?" And I thought, okay, all right. I know how the inner workings of the simulator works to a certain extent. And this sounds awesome. Yeah, let's do it. But I had no idea how to start. And it's okay. So we quickly got a lot of engineers in the room. And we said, okay, let's start. How are we going to build this? And after very lengthy discussions, we got nowhere. So I decided, okay, we're going to need to dig deep and really understand how are we going to get to our outcome. And I started with gathering any and all information I could find. We went to all of the simulator environments. We downloaded all of the documentation from SharePoint and Confluence, everything we could find. We even took a lot of photos. But this is really important because you're really building the information of what the current system does. You also need to talk to a lot of people. Because when you talk to many people, users of the system, people that support it, you really build the puzzle of what the current system is actually doing. Not just that, and this is important, and also a bit of a hard one, get the current system on paper. Really put it all in a single document or whatever works for you, because you really want to ensure that the information you gathered is worked out or processed in some form. And this is an awesome place to really start the feedback loop. Ask a colleague, hey, can you have a look at this? Is this right? And this is how you can really start the process and build on starting with your system. Then we can move to problem identification. And this is really important. Talk to the users of the system. When we integrated the electronic flight strips into the simulator environments, we really heard the users really complaining and said, wow, these training sessions are getting quite heated. And I thought, yeah, of course training an air traffic controller is no easy feat. It should be heated. But they meant it's actually getting quite warm in the room and quite noisy. So even though that sounded quite irrelevant to our project, this resulted in a very important design decision later on. So write down the problems, even if it sounds irrelevant. After we know what problems we have with a current system, and we know exactly what the current system does, or to a certain extent, we can go into requirements analysis. And this is where we're trying to write down the things we need to get to our outcome of a new simulator or a new ATIS system, and also address some of those problems with the current one, if any. One thing I felt I probably spent way too much time on during this step is trying to select the right tool for requirements analysis. We found that it's much more impactful to just prioritize the requirements. Because during this step, you want to have a lot of meetings and discussions with users of the system, with stakeholders, with your project manager, and having a set of prioritized requirements really helps conveying a message of these are the things we really need to do. And it could be as simple as using something like the Moscow method, which says that, hey, this is the things we must have to get to our outcome. These are the things we should have, but if we don't have it, we'll make the car run. And these are the things we could have. Those are the nice-haves. And it's also sometimes quite important to be explicit about what we won't have. And once we know this is what we have, these are the problems, and this is what we need to get to our outcome, we can go into the first fun part, and that's the conceptual design. This is really where I felt we've made some significant progress with the stakeholders, especially with designing the 360-degree tower simulator. What I found was, in discussion with users of the system, it's super vital to make it visual. It doesn't have to be beautiful. You can have drawings in paint for that matter, but the important thing is you want to make some high-level decisions here. And that's also why it's important to keep it high level. I initially started with functional decomposition, which we'll get to in a bit, but you really lose a lot of attention during meetings when you go into the weeds too early on. So make it visual, keep it high level, and that is a great way where you can get feedback from your users and your support early on in the process. And this is the moment where we can move on to the functional decomposition. So we've got a concept of what we want to design. So this is where we're going to take the blocks of functionality and split it into separate functional units and define some of the interfaces that we'll use between them. When I designed the 360-degree tower simulator, I got a bit stuck in a paper trap. So very important at this stage of your design, really don't go too deep. The purpose of having a functional decomposed design is really to actually anticipate what a technical designer would need, an expert in the field. This is really important for the next step. But keep in mind to don't go too deep, but anticipate, for example, what a network engineer would need. If they need to design a technical design, will they need to know that you're making use of multicast, for example? Or will there need to be some routing between products? Really try to anticipate the needs of the technical designer here. And one thing I really saw that Air Traffic Control the Netherlands as an organization really grew in the past few years was to have a shared technical design template. Because this really helps to create a shared technical vocabulary of sorts within the organization. And now we can get to the fun part. We're going for the technical design. What I've learned here is don't do everything yourself, people. Replay to the strengths of your diverse team members, because this is where teamwork makes the dream work. Oh, I love that. Yeah. I'll say teamwork makes the, and you say dreamwork. Teamwork makes the? Dreamwork. Yeah, that's it. I love it. Come on. Come on, Tim. Yeah, so when you get to the technical implementation, you'll quickly realize that this is going to need to iterate. For example, with replacing the automatic terminal information service, during requirements, the conceptual design, and even the functional design, I thought, let's go and migrate 3 network switches to 2 network switches. When we got to this point, well, needless to say, we still have 3 network switches. And one way you can really try and mitigate this is try to pull some of those lessons forward. And that is through designing initially only with the prototype in mind. Because then you can validate the technical design early on and feed those lessons through using that feedback loop into your technical design before you design for production. I also saw that designing for modularity really helps on the long term. So remember those very warm simulator environments? So to address that problem, we decided to migrate all of the hardware to a separate hardware location. This meant that we had to make use of enterprise KVM equipment, and that is you're extending your keyboard, your visual, and your mouse inputs to another location. And we designed it for modularity. So we had one unit that you can use at all of the positions. This also meant, on face value, it looked like a lot of waste because you've got a lot of open ports. But on the long term, it meant that we can extend the simulator, and our spares was only of one type, which made it much easier on the long run to support our second-line support. I also learned the hardware, and maybe there's a couple of on-premise guys here. Do not reuse hardware. So for replacing the ATIS system, we had a lot of very tight deadlines. And through reusing the hardware that we had, we could really speed up the process. But needing to commission a project to replace the hardware of a new system that you've commissioned really does not convey a very good message within the organization, and results in a lot of headaches later on when we got live. So be careful with hardware reuse. So now we've got a technical design, and before we go to the next step, this is a great moment to, almost like snakes and ladders, take the ladder, see if you need to feedback some of those things into your current system design, your requirements, and maybe you've identified extra problems. But make sure you update your documents that you've worked so hard on creating. So let's get to prototyping. This is where we're going to validate those technical designs. This is where we really want to make sure that we get some early on feedback for our technical design before we go and order all of the hardware or pay all of those perpetual licenses for our production system. This is an opportunity to spend some money to save some money. And it could be as easy as just investing in a representative test environment, which you can extend later on. But ensure that in the prototyping phase, you validate your technical designs or what you thought might work. For all of those components, you split up during your functional decomposition. And once we've validated our design, we can go into planning some integration. And this is where we're going to integrate all of those components that has been technically designed into one big system. One thing we've learned, and it might sound obvious to you, but in practice, it's not always the case. Start with one component at a time. For when we introduced the new ATIS system in our test environment, it really helped to start with the weather interface and then the rest, because you can isolate problems early on instead of spending a lot of time trying to debug all of these different interfaces where problems might lie in your system. Yes, start in a test environment if you can, but it could also be that you have some constraints. We had, for example, an interface that was only available in production. That gave me quite a bit of stress, to be honest. But you can mitigate this ahead of time through, for example, the use of test tooling. But even though test tools are awesome, be cautious, because sometimes test tooling come with some undocumented features. So for one of these interfaces for the ATIS system, we spent a lot of time trying to debug why the application was not accepting our test messages. And after a few calls with the suppliers, and we realized that we missed a single carriage return at the end of the message. Now, we learned that, but about a year later, I overheard some of my colleagues having a similar problem. And believe me, they were not impressed when I told them that they could have saved a couple of hours if they only had a single carriage return at the end of the message. So be aware of using test tooling, but they are awesome. So now we've integrated our systems, hopefully in our test environment, and we can go and think about how are we going to test this? Now, hopefully you can make use of automated testing, which is great. I mean, use it where you can, but it isn't always possible to automate everything. So try to invest in building a reusable regression test set. This really helps to build some confidence later on with new system releases. Just having a couple of tests which you can run every time, which will help you identify if there's some regression in the system and ensure that you know that the system does what it should be doing. Also important, you've worked really hard on those requirements. Include them in your regression test set. Test those requirements, because that really helps conveying a strong message towards your stakeholders and your users that you've included, hopefully, when you created those requirements. And finally, consider representative user acceptance testing. I've seen time and time again how an air traffic controller uses our system, and I thought, I did not know that's how they're using it. So a user might use your system differently than you designed it, or that you even thought that they would use it. But feed those lessons learned back into your regression test set, or even better, your automated testing, and ensure that you know that you can test those exploratory testing that they've done later on. And now we get to the fun part. We're going to production. So for the simulator environments, we had the opportunity to plan for quite large maintenance windows. We could work throughout the day, and that was quite nice. But working on the operational system, we really had very tight time constraints. So when you're working with a production system with really tight time constraints, we found that it is absolutely vital and reduces a lot of stress to have the rollback possibility. If you know that they have flights coming in at 5 a.m. and it's 4:30, you just know you can easily roll back to the previous system and try again another time. Not only that, one of the things that has given me a lot of peace of mind is to just have a list of steps which you need to perform at night. Because I can tell you, for those that has done a lot of work at night, such a run book, it really is your friend after 2 a.m. when you can't think that clearly anymore. So we get to the last part. If you haven't incorporated monitoring and maintenance in your design, take that snakes and ladders back and go and incorporate it. And design with M&Ms in mind, Tim. Really try and consider all support lines. This is probably the place where I think we could have improved our process the most. Because now that I'm also part of the support team, after needing to go and grab technical logging off of an air-gapped system for the 10th time, you really realize that this could have probably been done better. Not only that, this is a great place where you can invest in some really high-quality standard operating procedures. Nobody likes writing them, but if you invest in them during this time and really test them as well, you can really shift left a lot of the responsibility into your support or your ops environment. And probably one of the most fun and interesting things you can do is to let other people test your procedures and sit next to them. I've seen time and time again how steps that look so clear to you really seems a bit fuzzy to someone else. And learn from that and improve your procedures. So throughout this entire implementation of this structured approach, really keep the following things in mind. Document everything. This is very hard to do, and not everybody likes it. But I've had countless times that people call me about a year after we've implemented something, and they ask me, hey, Gabriel, we're trying to extend the simulator. Where can I plug in this cable? Or we need to replace something. How can I do that? And having all of the documentation in a single place and very well documented means that you don't need to dig that deep into the design mind you've had a year ago. So that really helps. Really try to also establish a feedback loop early on. And this means it could be as easy as just asking a lot of colleagues to review documentation and really try to have some sort of a mirror to help you along the way. And always try to give credit where credit is due, because people spend a lot of their time, sometimes time they don't really have, to review what you're trying to do and learn from it. For example, for this talk, a big shout out to Sohan for helping me structure this talk, and for my team at LFNL for listening, talking about structured approaches for the past couple of weeks, and also to my wife for being such a great mirror. This is also a great way to transfer knowledge ahead of time from your design team towards your development or your support team. And it really helps later on when you need to give the stick to operations to go and support and ensure that your system can run, hopefully 24/7. When working with people, I'm always saying, try to sell the design. If people ask you, hey, what should this IP address be, or what type of hardware do we need? Always refer to the design. Tell them, hey, you can find it, great that you ask, but look in paragraph 7.4, and here's the link. And this really builds some confidence in, hey, we've got a bigger plan, this is where we're going, and this is where you can find the information you need. And finally, when you're designing systems or you're part of a team, you'll be faced with a mountain of decisions. And there really isn't one right solution. It always depends on the context or the situation. So let's wrap it up. If you're working in a high-stakes environment, think of that project that you've taken with this mission today. It can help you to use a structured approach, even if it's in a high-stakes environment or in just your side hustle project, to get some context and know where you're going. It can also help to break down some of that communication complexity between teams, because teamwork makes the dream work. That's right. Include your users and support early on. That way, you can really build for users while keeping monitoring and maintenance, those M&Ms, in mind. Always get feedback, ask for feedback, and always give some feedback, and then iterate. So important. And most of all, have fun. Don't be scared to fail. Ask a lot of questions. And just like the clapping game, even if you tend to start doing things without reading the requirements, start with system understanding and identifying those problems. And then you get to the requirements. If the requirements change, feedback and iterate and update those requirements. If your team lead doesn't have the complete picture, send them the link to your design and tell them, this is where we're going. Don't be scared to do all of the steps, because you just might have some fun and a bit of confusion. And finally, remember, humans are complex. Even simple coordination is hard at scale. But when we're doing that together, you know that teamwork makes the dream work. Exactly. So looking back at your project, think of how might such a structured approach have changed the outcome of the project you've worked on. And when you're done with this weekend, on Monday, where are you in that structured approach? And what can you start on to start your journey into systems design? And feel free to share that with me. Through my blog, you can find all of the links where I'm available online. Send me a LinkedIn request, and let's chat about our lessons learned and learn from each other. Thank you, DevOps Days Amsterdam.